Welcome back to the Deep Dive. This is the show where we take some pretty complex sources and we distill them down to get you that intellectual shortcut you need. Today we're looking at something very specific, but it's hugely important in enterprise cybersecurity. We're at the intersection of these massive business platforms and the tools built to, well, police them. Our sources are all centered on a new open source release from Google and Mandiant. So yeah, names you can definitely trust in the security world.
Absolutely.
Our mission today is to unpack their new tool. It's called AuraInspector. We want to understand the very precise security challenge it was built to solve inside one of the biggest platforms on Earth, Salesforce.
And that focus is just so critical. This deep dive, it's not really about a simple software bug. It's about how incredibly difficult it is to control data access in a system like Salesforce Experience Cloud.
So it's a complexity issue.
It is. Anyone who manages data governance knows that complexity is, it's the ultimate enemy of good security.
And the fact that this tool, AuraInspector, even exists, it really highlights the challenge that Mandiant found. They pointed out that a full security audit of these environments is, well, it's almost impossible to scale.
Right, because the data sharing rules in Salesforce are configured at so many different levels that all interact.
Multiple levels, okay.
Exactly. Just think about it. You've got your role hierarchy, you have profile permissions, sharing settings, organization-wide defaults, group memberships, and they all stack on top of each other. When they interact, trying to audit that manually is a lost cause for an administrator.
So you need an automated system.
You do. You need something that doesn't just check the rules one by one, but checks the final, the net outcome of all of them working together. And that's the gap AuraInspector is built to fill.
Okay, so let's set the technical scene a bit. We're talking about Salesforce Experience Cloud applications.
We are. These are basically the websites and portals that Salesforce customers build to expose their data to outside users.
Like partners or customers or sometimes just unauthenticated guests.
Exactly. And those user interfaces, they rely very heavily on a technology called the Aura framework.
Okay, let's unpack that architecture for a second. The Aura framework, it's component-based, right? It handles the user interface on the client side. So what's the security angle there?
The security implication is that every time a user wants to see data, like fetching a list of contacts, the component in their browser has to talk to the server.
Right.
It does this through server-side controllers, and it accesses them through what we call the Aura endpoint. That endpoint is the critical security boundary.
So the Aura framework makes the page look right, but the Aura endpoint is the choke point that actually goes and gets the data from the database.
Precisely. And that's where the core risk that Google and Mandiant identified really lives. It's the sheer complexity of those object sharing rules. It means administrators are constantly struggling to find potential misconfigurations.
Let's try an analogy to make this a bit more tangible for you listening. Imagine your data governance is like a huge medieval castle.
Oh, I like that. So if your profile permissions are, say, the country you're born in, your basic citizenship rights.
Right.
Then the object and field level security settings are like the local laws about what tools you can carry or what doors you're allowed to touch.
Okay. And the sharing settings and role hierarchies.
Yeah.
Those are the actual security guards and the specific keys, right? They decide which rooms you can enter based on who you are.
Exactly. And when all those systems stack up, citizenship, local laws, and the guard's specific instructions, it becomes incredibly hard to calculate ahead of time which files any one person can actually read.
And that difficulty, that's the heart of the problem.
It is. That multi-level complexity is why security auditing at scale becomes what the sources call a real challenge. You might have a great rule somewhere, but if another rule lower down accidentally grants access to too many people, the whole system can fail.
Which brings us right to the point of attack. Mandiant and Google's analysis found that because of this audit problem, the Aura endpoint, that data choke point we mentioned, it's one of the most commonly targeted endpoints in these applications. Attackers know that complexity leads to mistakes.
And what's fascinating here is how they target it. This isn't about, brute forcing a password. This is about taking advantage of those misconfigured permissions.
So you find a component that delivers records, and if the endpoint is misconfigured,
then that data can be exposed to unauthenticated or external users.
Okay, let's pause on that. Is Mandiant saying the Salesforce platform itself has a fundamental flaw? Or is this more about human error admins just setting things up wrong?
That is a great and a very necessary distinction to make. The research consensus is that the platform is robust, the flaw comes from the customization and the complexity needed to manage it.
So it's not a zero-day exploit in the code.
No, not at all. The risk is just how hard it is to correctly calculate the final permission set when you have hundreds of sharing rules. It's more of a structural exposure risk.
I see. So the system is designed to return, say, a limited set of records. But the problem is that the permissions are accidentally way too broad because of that complexity we talked about.
Exactly. And now we get to the mechanism of how they pull out too much data. This is where it gets really insightful. The sources say that specific query patterns can bypass the intended limit.
And what kind of patterns are we talking about here?
We're talking about basic, totally routine user functions that you see in almost every web app. Things like sorting and pagination.
Wait, sorting and pagination.
Yep.
Okay, this is where it gets really interesting for me. We're talking about a user clicking sort by date or the little arrow for the next page. How do those simple things become a massive data leak?
It's all about a breakdown in enforcement on the server side. So when the Aura component in your browser requests data from the Aura endpoint, it asks for a specific page, right? Like records 1 through 50.
Sure, makes sense.
But Mandiant's research found that some common ways of implementing the server controllers, they fail to apply that strict row limit when they're processing a complex sort request.
Oh.
So because the permissions, due to that multi-level misconfiguration, already grant the user access to, say, thousands of records, the server controller just goes and gets the entire data set the user is theoretically allowed to see.
So the server grabs 10,000 records because some deep-down sharing rule says the user can see them, even though the user's browser only asks to display the first 50.
Precisely. The browser component then gets this massive 10,000 record response, and, it does its job. It only displays the 50 records you asked for on the screen.
But the whole data set, all the names, the IDs, the sensitive fields, it was all transmitted over the network.
All of it. In the HTTP response body. So an attacker, or even just a curious user with a simple proxy tool, can just grab that network traffic and see the full, unfiltered data set.
That's staggering. It's a structural misconfiguration that turns a routine function into a weaponized data leak. It's a failure of the permission logic right at the moment of execution.
And that's exactly why a tool like AuraInspector is so necessary. The security community realized that manually debugging thousands of lines of permission configurations is, well, it's an impossible job. You need a tool to test the outcome.
So the experts at Google and Mandiant responded by building the solution, AuraInspector. And they released it as an open source tool, so it's free for anyone to use and audit their own Salesforce setup.
Which represents a real shift in defensive strategy. If you can't be 100% sure you've configured the system perfectly, then you have to build tools to test the result of that configuration.
And how does it work? It's a command line tool.
Yep, a simple CLI tool. Its main job is to systematically query those critical Aura endpoints and then analyze the network responses. It's looking for those signs of excessive data exposure.
That telltale sign of a massive, unfiltered data set being sent back when only a small page was requested.
Exactly.
It's essentially acting like a friendly attacker, probing the system for these specific failures. What exactly is it checking?
It checks a few different layers that contribute to the risk. For example, it audits the record list components to see how they handle sorting and pagination. It also verifies the underlying object permissions.
Okay.
And crucially, it also looks at configurations around self-registration and guest user permissions. Because if a guest user can hit a misconfigured component, that exposure risk goes from internal to, well, global.
That brings up a practical point. If it's actively querying the endpoint, does the tool risk setting off alarms in, security monitoring systems? Or is it a passive check?
That's a highly relevant question, for sure. AuraInspector is designed to simulate a legitimate user query. It's just a query that's maybe a bit more aggressive in how it sorts things.
So it's not trying to be stealthy.
Not really. Its goal isn't stealth, it's thoroughness. Security teams would normally run this as part of a controlled audit where they'd whitelist the IP address it's coming from.
And this is its real value proposition for you, the learner. It automates the kind of verification that manual checks just can't do. It confirms that when a user asks for page 1, the system isn't secretly handing them the entire database over the network.
Precisely. It lets an admin pinpoint exactly where those complex multi-level sharing rules have created a functional exposure. By targeting that large dataset retrieval, the sorting and pagination issue, it tells you where your castle walls have a hidden, unintentional service elevator.
So what does this all mean for us? We've done our deep dive on AuraInspector. We've identified a very specific high-risk security challenge in Salesforce Experience Cloud.
Right, that inherent complexity of the sharing rules.
And how that leads to an exposed Aura endpoint where routine functions like sorting can suddenly become massive data leaks. And we've learned about the precise new tool, AuraInspector, built by experts at Google and Mandiant, designed to fix that problem by automating these complex checks.
It's moving auditing away from just analyzing the schema towards verifying the functional outcome. And understanding this is so important because it gives you this fundamental insight into how modern security professionals have to manage these incredibly complex environments.
You can't just debug every line of the permission schema anymore.
No, you can't. So you build tools that test the effect of that schema. You check if the final data access outcome actually matches your security policy. It's modern auditing directly addressing the reality of system complexity. And if we connect this to the bigger picture, given that the problem really stems from the complexity of rules configured at multiple levels, our inspector audits the outcome of those rules.
Right, the final data flow.
Which raises a really important question. When you're dealing with these massive enterprise systems like Salesforce, where customization and complexity are just growing every single day, is it even possible for any setup to truly eliminate all the blind spots? Or can we only ever hope to build better, faster tools like AuraInspector to monitor and detect the exposure after the complex rules have already been set?
Design versus detection.
Exactly. It's a fundamental question we all need to think about as these platforms just continue to grow.